Hi, and welcome to this webinar introducing you to the SafeGuage for Grains program. My name is Kirsten Barlow and I'm a Senior Research Scientist with Agriculture Victoria based at Rutherglen. Along with my colleague Dr. Tabo Kumaran, we have developed the SafeGuage Dairy and Grains tool. This work was funded by the Australian Government, the Department of Economic Development, Jobs, Transport and Resources in Victoria and Fertilizer Australia. Today I'm going to give you a quick run through and introduction to the SafeGuage for Grains program. If you're interested in the dairy tool, there is a webinar by Dr. Kumaran on the dairy program that you can watch separately. The tool has been developed for use in training of FertCare consultants and agronomists to develop their understanding of the relative magnitude and risks of nitrogen losses in grain systems in the high rainfall zone. And for the purposes of the tool, we've looked at the high rainfall zone as areas with rainfall greater than 600 millimetres a year. It has been developed with a limited scope of application and only has a selected number of soil types, climate stations across the cropping regions. Through the presentation, I'll just cover quickly how to access and download the tool, give you a bit of an overview of the grains module, and then just step through using the tool. So accessing and downloading the tool. When you join through the FertCare program, you'll be sent a web address listed up here. You need to click on that address and the screenshot below it will come up. You just need to follow the 3 steps on there, which are basically click to download the tool. Once you've clicked on the orange button, it will download the information on the tool as a zip file. You just need to find that on your computer and unzip it to extract all the files. Once you've done that, to open the tool, you click on the index.html file and that will open it up. If you've got several different browsers, probably Firefox is a better one to use. If you do open with Internet Explorer, you will get a couple of warnings come up. These are outlined on the download page and just click accept for those. So once you've got the tool up and running, it will open up on your computer and you will see a screen similar to this. And that means you're good to go. So in terms of the SafeGuage for Grains module within that, it's developed as a user-friendly tool that qualitatively assesses the potential risk of off-site movement of nitrogen as a result of farm management and fertiliser use. It does not provide a quantitative assessment, on the movement from an individual farm or property. So it's an indicative tool to help understand the risks, but not actually quantify that this property in this year would lose X kilograms. The tool has a database of runoff, soil drainage, water drainage, soil moisture, crop growth, and climate information that sits behind it. And you can't see any of that. But basically that data is then combined with information on your site characteristics, so the location, the soil type, your slope, distance to watercourse, crop management, and those are then fed into a range of mathematical equations, which you can't see, to give an indication of daily runoff, water drainage from below the root zone and soil water, as well as daily crop growth and a daily nitrogen balance. This information is then combined together to create your risk rating. Oops. So I'm just going to change across to the tool in Explorer, so just bear with me for 1 second. That one. Okay, so now we're in Internet Explorer. We've got the tool up live. As you can see, there's a tab for dairy and then there's a tab for the grain tool. I already have one assessment saved on here. You can save up to 10 individual risk assessment so you can compare between them. But for now, I'm just going to set up and walk you through how to set up a scenario. So to set up a new assessment, we click the orange button and give it a name. So we're just going to call this a base assessment. And then we come into here. So it tells us what their name is. We can choose to export the results or not, but I'm not going to worry about that today. We then go through and choose a state. Western Australia will be added to this list shortly. So once you've selected a state, it comes through with a map of where the weather stations are. So you just choose the one you want to look at, and we're going to look at in the southwest. And then we choose a soil type. Now, as you can see, as we move through these, the red boxes show the texture and the drainage class, or the saturated hydraulic conductivity of the two soil profiles. So we're just going to go with that one. Okay, so that's the first sheet done. We then go through to block management. We've got two crops within the tool, canola or wheat. Today we're going to do a run for wheat. We then choose our stubble management. We're going to go with retained slashed and a cultivation technique. So we're going to go with a direct drill approach. Now the block characteristics give an indication of the risk of water leaving your property and actually reaching a surface or a groundwater system. So our property is going to have quite a low slope. It's going to be greater than 300 metres from a surface water system, and it's going to be 3 to 5 metres down to the groundwater on this site. And if we come down here to year, I'll scroll down a bit so you can see the list. You can choose an average dry or a wet year, which are just kind of an average year over the data set, or you can choose a specific year to compare. In this scenario, we're going to use 2013. And finally, we want to look at the nitrogen management on that property. Just before we move on though, when you select a year, it gives you a growing season rainfall for that year. That's from the sowing date through to harvest. And the sowing date is automatically set within the program based on rainfall and getting an adequate rainfall for germination. So in terms of the initial soil nitrogen status, this is very important in setting up the soil properties at the start of the season. So you get to choose either whether a pre-sowing soil test has been done, and if it has, you click yes, and we will put in these details. But just for a second, I'm going to say no. So we haven't done a soil test, but for the model to work, we still need to have an indication of what the initial soil nitrogen content is. So we calculate this based on an estimate of your soil organic carbon. So if you've got low, moderate, or sort of high organic carbon within your system, so you'd select one of those, and that will automatically set a starting nitrogen concentration for you. But for this scenario, we're going to say yes, we've done a soil test. We did the soil test on the 3rd of April, so you just go through and select your month. And we did it on the 3rd. When we did the soil test, there were 20 milligrams per kilogram of N of nitrate N. We didn't measure ammonium, and that's okay. If it's not measured, it will automatically estimate what the ammonium in the soil is based on the nitrate. And we enter a sample depth, which is actually only 10 centimetres, not 110. So that sets up the conditions at the start of the season. In terms of fertilizer management, we have a database of different fertilizers, so we can go through and select a fertilizer that we're putting on. For this scenario, we're going to apply DAP. We're going to put it onto the crop on the 9th of May, so just before sowing. And we're going to put on 50 kilograms per hectare of DAP. So then we can save that. And it'll come up here telling us the assessment's been saved, and we can then calculate the risk. Oops, except the button moved. Okay, so this is our grain risk summary, and I just want to walk you through it. So up here, the current assessment, which is what we've just entered in, is the base assessment, so it tells us what title it was, and all the text in black relates to that. So everything on this screen at the moment relates to that assessment that we've just entered. So these gauges give us an indication of how many cumulative days of risk there were within the season. So it's not saying how much nutrients or nitrogen potentially lost from the system. It's just saying how many days were we in a situation where nitrogen could be exported from the property. So for this scenario, we had a very low risk of surface runoff and a moderate and moderately low risk for groundwater and denitrification. There's also a little section in here called pre-sowing denitrification risk. Basically, that's at the moment is saying a lower risk if there is a very wet summer or early autumn leading up to sowing, where the soil is wet and conditions are right for denitrification. That will show that there might have been a higher risk of denitrification occurring. And that's important to consider when looking at the nitrogen demands of the property. But once again, that's not actually showing the magnitude of loss, that's just showing that the conditions in the soil were conducive to potentially losing nitrogen through denitrification. So if we come down here, we can see this graph shows the growing season. We sowed here on the 9th of May, and you can see the green line is the denitrification risk, the red is the runoff risk, and the blue is the drainage. As you can see, there's only a couple of days where we've got a risk of runoff, more days where we've got a risk of denitrification, and more time again where there's a risk of N export through drainage. The risk index on the axis can go up to 8. 8 is the maximum number it can reach, and that's really an assessment of the magnitude of losses that we might see. And the final part of the summary is down the bottom, and that's sort of an indicative nitrogen balance for that scenario. So the initial soil is somewhere between 80 to 100 kilograms of N per hectare. We applied 9 kilograms of N per hectare of fertiliser, so we didn't put a lot on. We got in-season mineralisation of nitrogen. We got crop uptake of 80 to 100 kilograms of N, and there's sort of indication of potential losses from a paddock and below the root zone. So it's not actually a measure of how much might actually reach a stream or the groundwater. So the other thing we can do is, remember, I already had a saved scenario, and my saved scenarios come up in here, and I can then compare how the two assessments look compared to each other. So I can then click on that, and what you can see is the risk of denitrification increased in terms of the number of days of risk, but the surface and groundwater didn't. The pre-sowing denitrification risk didn't change. What we did in this second scenario is we applied, I think it was about 100 kilograms of urea in September, which is why we've suddenly got much higher risk of nitrogen export later in the season, simply because there's more excess nitrogen left in the system. So then you can see when the losses were occurring, and then you can see once again the relative balance between the two systems. So that's the tool, that's how it works. Enjoy having a play with it. Yeah, I want to go there. And if you have any further questions or want some more information on the FertCare program, their website's on this screen, or you can contact myself, Dr. Kirsten Barlow. Thank you and enjoy.